Hey everyone, and welcome to this tutorial on how to build with Superfluid. Today we'll be going through a simple contract called the money router, which is designed to help you get started with the constant flow agreement and creating money streams in Solidity. So the contract today will be very simple. We'll walk through how to create, update, and delete streams into a contract, how to do so using our new ACL features to allow you to provide a kind of access control to other addresses over your ability to create, update, and delete streams. We'll also work with the Superfluid SDK to write scripts that interact with our contract. We'll get into what super tokens are a little bit at the beginner level. And yeah, this should give you a great base you can start with, then go on to more advanced things like super apps, which can receive streams and redirect them other places using callbacks, right? So I'd recommend watching this before you watch the tradable cash flow example, especially if you don't have a ton of Solidity experience. This will give you a great base. Okay, so you can see here I have the Superfluid console up. We're not really going to use that yet, but we'll come back to this a little bit later. I do just want to preface this entire tutorial and say that the Superfluid console is a great resource for developers looking to build on Superfluid. You can use this to track streams, super token balances, super apps, instant distributions, all kinds of good stuff. You can also even write your own custom subgraph queries here in line as well. So we'll come back to this a little bit later. But what I want to show you is where to find this example in our GitHub. So if I go to our protocol monorepo, you can find the money router example inside of the examples folder. Let me zoom in a bit. Let's go to the examples folder, inside of the beginner examples, and in the money router. Okay, so you're welcome to clone the repo or fork the repo and get started here. We have a good test suite, which shows you how to set up a test suite. We have some scripts, which allow you to interact with the contract itself. We'll go through many of these today. And then you have the contract, which is a completed version of what we're going to build together. This version has some more around access control that we won't quite use in our example for today, just for the sake of time. But this does have a more professionalized access control feature set. Again, it has like an owner, it has a list of accounts that are whitelisted, all that good stuff. But for us, what we'll do is we'll go through how to send a lump sum of money into the contract using a super token transfer. We'll then show you how to create flows into the contract using the ACL features and these by operator functions. And then we'll show you how to either A, withdraw functions from the contract, or B, just create streams from the contract and work with them. Okay, so this will be a pretty simple example, but let's go through it together. Okay, so if we go into this folder, I have a special folder up here where I don't have the example completed. This is just a workshop section. But here, what I have is an empty contract with just the imports and constructor setup. Okay, so we'll get into the contract logic in just a second, but to give you some context, what we need to do is import things like the super token interface, Superfluid host interface, which is this iSuperfluid. And we don't really quite need a super app. I'm not really sure why that's there. We can remove that. And then we also would want the constant flow agreement interface and the CFA library, right? Which will allow us to very easily create, update, and delete streams using Solidity. So for those of you that don't know, the way to think about the Superfluid protocol is that the host is like the brain of the protocol. To instantiate things like the CFA library, you do need the address of the host contract to do so. We can find that inside of the console. You can go to the protocol section and get lots of information about the Superfluid deployment on each network. So if I wanted to find the host address on Polygon, I would just copy this, and then we have the same thing for things like Avalanche and Gnosis Chain and all that good stuff. Okay, so that's where you find the host address. What we can do once we have the host address is, in our example, we're going to use it inside of our constructor to initialize the CFA v1 library. So the CFA v1 library is going to abstract away some of the complexities of creating streams. Under the hood, what's happening when you create a stream is I'm actually making a call to the Superfluid host contract, which then in turn makes a call to the CFA, which then opens the stream, right? We're going to abstract that away. You'll see under the hood, the function that's called on the host is called called agreement. And I can even go in and I'll quickly show you where to find this. Let's go back into the repo. It's a little bit easier to navigate over there. But if you ever really get curious and you want to see how the CFA library is working under the hood, you can come into Ethereum contracts in our packages folder. You can go into contracts, apps, CFA library, and you can see, like if I look at create flow, we can see what's happening. So under the hood, we're calling the host, call agreement. We specify the agreement that we're going to be interacting with. In our case with the CFA, it's going to be the CFA. If we're using the IDA, it'd be the IDA, the instant distribution agreement for one-to-many discrete transfers. And then we encode this call here to the constant flow agreement contract, right? So we specify we want to create a flow. Here's our parameters. And if we want, we can pass in some user data. We're not going to get into user data today. You can find information on user data elsewhere in our docs if you would like to, but we'll keep this simple. So that's the CFA library under the hood. One key piece, though, is that in order to initialize the library, we need to pass in the address of the host and the CFA so that this struct is initialized and can be used to make these calls to the host contract on the right network. Okay, so what we need is to pass in the host address. In our case, we're also passing in an owner inside of this money router contract because that was used for some of the access control stuff. That's kind of optional. We're not going to implement it, but I still want to include that parameter. We're going to run a check to make sure the host address is not the 0 address. We'll initialize the owner by setting the owner equal to owner. And again, I'll zoom in a little bit. And then here inside of our CFA v1 variable, what we're going to do is initialize the library. So the first piece of this is we have to pass in the address of the host. In our case, we're going to get that already, so we can just pass the host in down here. And then we need to get the address of the constant flow agreement for the network we're going to be working with. I could, if I want to, just grab the address of the CFA from the console. So you can see we have CFA v1 here for whatever network we want to work on. I could just copy paste that in. But for the sake of efficiency, I'm using this fancy piece of code here to call a function on the host contract to get the agreements that we're going to be working with, which in our case is the CFA. You can just pass in the hash of this string here, and you'll get the CFA contract returned to you. We can grab the address of that, and voila, we have the CFA address. Again, you could keep it simple if you like and just include the CFA as an extra parameter. Okay, so that's the initialization step. Once we've done that, we can go ahead and start writing our contract. So our contract needs a couple of things, right? What is our contract going to do? Well, let's walk through it. So I have a slide here we can take a look at that I used for a recent workshop, which gets into this in a bit more detail, okay? So within the money router, we're going to create an application that can receive incoming streams and allow you to send outgoing streams. We're not going to create a super app, right? It's going to look a little bit like this, but it's going to be less fun, okay? So if you want to use super app logic, you can go in and work with the tradable cash flow after this, but this is going to show you how to manually, again, send streams into the contract or send discrete transfers into the contract and then send streams out of that contract, okay? So fairly straightforward. Let's get into it. Okay, so the first thing that we're going to need is the ability to send funds into the contract in the form of a discrete lump sum. We're going to create a function in Solidity to make this possible. This will be fairly straightforward and show you how to work with super tokens and show you that super tokens are really no different than ERC20s when it comes to transferring in discrete lump sums. So let me create a function called, I'm going to indent a bit. We call it send lump sum into contract. We'll pass in an amount, so it'll be a uint. Make it external. And what we'll do is call token. I guess we need the token address too, right? We can't just not pass in a token. So we'll specify the token. This will be type of I super token, and there will be an amount. And then what we'll do is just call token.transfer from address of this, I guess message sender first, into this address in this amount. okay? So what we'll have to do before calling this is an approve step outside the contract first. So we'll have to use the SDK to call approve on the super token we're going to use. But you'll notice here that even though it's a super token, we still have this ERC20 method called transfer from. So super tokens are required when it comes to working with Superfluid and creating streams and things. I'll show you how you can get some free test tokens in just a second to allow you to get these super tokens in the first place. But again, this transfer from logic is exactly the same as what you're used to on ERC20 contracts, okay? So that's pretty simple. Okay, so next what we'll do is we'll create a flow from the contract to some receiver, okay? So I'll create this function. We'll call it function create flow from contract. And then the first argument we'll take is going to be the receiver. This will just be an address. Then we'll pass in the token because we didn't know what kind of token we're going to be using. Then we'll pass in a flow rate. So the flow rate is the number of tokens I want to send per second to the receiver in way. So it's denominated in an 18 decimal amount. And the type is always going to be an int 96. Okay, so in order to call create flow, what I can do is just call CFAV1, which is the variable which corresponds to the CFAV1 library inside of my contract. Dot create flow. And you can always see, for example, inside the library, what the order of parameters is. Okay, so we have receiver, token, flow rate. I'll pass it in the same order. So we have receiver, token, and flow rate. And boom, this is going to create a flow from the contract to our receiver for this token at that flow rate amount. Wonderful. Next, let's create an update function. So let's say that I have a stream coming from the contract to a receiver, and I want to update it, right? Keep in mind that you can only have one stream open as the sender to a given receiver for each token, right? So if I have a stream open to you from the contract, I can't create a second stream to you from the contract. I'd either have to delete the first stream and open a new one again using create, or if I just want to send you more money, I'd have to update the stream to reflect the additional amount that I want to send you. So let's create this update functionality. So we'll call this update flow from contract. And the parameters for updating are exactly the same. So it's going to be receiver, boy. Oh boy. Token, flow rate. And keep in mind on the update call, you cannot update a stream that doesn't already exist. So if you're trying to call update and the token and the stream already exists for that token, you're good. But if the stream doesn't exist, you're not good. And even if the stream does exist, you must make sure that the flow rate is different. So same thing here, CFAV1.update flow, and we'll pass in the same params. Alrighty. So finally, we need to also be able to delete the flow from the contract. So this one will be pretty simple. We don't need a flow rate for this one because there is no flow rate, we're just deleting. So then we'll have to put in the receiver and token. All right, and let's make sure we get the parameters right on this one. Let's do a little search. So to delete the flow, we need to pass in the sender, receiver, then token. In our case, the sender will just be address of this. The receiver is the receiver we're specifying, and the token we're using is token. So make sure I have the actual token param here. And boom, we have the ability now to send money into a contract, then create, update, and delete streams into that contract, or from that contract rather. Now what we need to do is add functionality to allow us to create streams into the contract as well, right? Because that's half of this equation. We don't just want to be able to send a lump sum in. We want to be able to send streams into the contract. To do that, I can't quite use these functions, and I'll explain why. So if we want to create a flow into contract, and we want to do so from the message.sender on the call, how would I go about doing that? Okay, so if I create flow into contract, we don't really need to specify the message.sender because it's just going to be implicit in the call. So I guess we would just need to pass in the token and the flow rate, right? So then if I were to go to cfav1.createFlow and say, okay, I want to send this from the message sender to the contract, I guess the receiver is going to be the contract, right? So I'd say address of this, then I would say the token, then I'd say the flow rate. So if I run this, what do we think is going to happen? Well, what would happen is it's going to fail, right? And it's going to fail with a specific message. The message it's going to fail with is that you can't create a flow to yourself, effectively is what the message is going to say. And what this line of code is doing is it's basically trying to create a flow to the contract itself, which isn't going to work. Because the message.sender on the overall function call is different from the message.sender on this call. The message.sender on this call is actually the contract. That's how Solidity works, right? If you were to call a function like this here, the message.sender is the contract itself, which poses a problem for us, right? Because it means that we can't just use Solidity to open a stream from us into the contract, which is something you might want to do, right? You can use the SDK to do that all day long, but you might want to have a function in Solidity to allow you to create a stream into the contract. So the way we'll do this is use our new access control list features to grant permissions to the contract to spend money on our behalf, to create streams on our behalf. And we'll then be able to, just like you can do it with the approved transfer from features on the ERC20 token, we'll be able to effectively pull money from the message.sender into the contract using that syntax. So I have to add something here in this create flow. I have to actually call this create flow by operator. All right, so create flow by operator, what I need to do is pass in the sender, the receiver, the token, and flow rate. So the sender is actually going to be message.sender. The receiver is going to be address of this. Then we have the token and the flow rate. All right, so this isn't going to work out of the box. We're going to have to run a script to approve the contract, to open streams on our behalf, and to update and delete streams on our behalf. But we'll leave this here for now and handle those approvals instead of our scripts. Okay, so same exact thing with updating. I can do the same process where I can just call this update flow into contract instead. Same thing, we'll just pass in the super token and the flow rate. And we'll just call cfav1.updateFlow by operator. And same thing, message sender, address of this, token, flow rate. Finally, we can call delete flow into contract. So this one's going to be a little bit easier. So we can, and for this one we just need to pass in the token. We can use the by operator functionality for this one too, but we actually don't need to. And we don't need to because the receiver of a stream can always delete that stream, right? If I'm receiving a stream, I can't just update the stream so that I'm receiving more money or anything like that, but I can delete it. I have the ability to reject an incoming stream. So for this one, we can just call cfav1.deleteFlow. And it's the same exact function as delete flow from contract, right? Except with the parameters are a little bit different, right? In this case, it's going to be delete flow message.sender, address of this, and token. Okay, pretty easy. The final function I'm going to add, just for the sake of safety, in case we mess up, is going to be called withdraw funds. And this is just going to be a single withdraw function that's going to let us just drain the contract if we need to. And we'll just call token. I guess we want to pass token here as well. So this is just the inverse of the send tokens into contract function, the send lump sum into contract function. So we'll call token.transfer to message.sender in the predefined amount. Okay? This contract's basically done, right? We have our ability to send a lump sum into the contract. We have an ability to withdraw funds from the contract. We then have the ability to send streams from the contract using this create flow, update flow, and delete flow syntax to work with the CRUD operations for sending streams from the contract. And then we also have this create flow into contract, update flow into contract, and delete flow into contract functions, which will allow us to create streams into the contract using Solidity. So what we'll do is set up our environment variable file to make sure that our hard hat config is all good. We will deploy this contract to Goerli and work from there. Okay, so I've set up an environment variable file that's based on the template that you'll see inside of the repo. I've also installed dependencies so that I have them all set up. And then inside of hard hat config, this should already be configured properly, especially if you're going to use Goerli. But you can see here I have both a slot for URL and a private key or a set of private keys that I might want to use inside of this application as I deploy it and interact with it. So to deploy our contract, I have a deploy script here that will allow us to get the contract using the ethers contract factory, little helper here. And then we can go in and pass in the address of the Superfluid host and the address of our owner. So in our case, what we're doing to get the address of the Superfluid host is first getting the RPC provider we'll use for the deployment inside of deploy.js. Here in my case, it's just process.env.goerli URL. And then inside of this framework initialization section, what I'm doing is initializing the Superfluid SDK. So here what's happening is I am getting the chain ID of this provider inside of the chain ID section. I'm passing the provider in here. You can ignore these 2 bits. These actually aren't quite necessary for what we're about to do. And then I'm also getting these signers from the ethers.getSigners little helper as well. Okay, so when I create the money router contract, what I can do is deploy it using this line. And to get the address of the host, we can parse it from the Superfluid SF object using this sf.settings.config.host address. That will give us back the Superfluid host address. Remember, if we want, we can always get it from here if we need to. I'm just doing it in a way that can expand to other development environments. And then we also need to pass in our owner address because we do have this as a parameter. Again, this is for access control things that we didn't go through together, but you'll see it inside of the main example folder. So I'll pass in the owner, and the address I'll pass in for the owner is going to be the first signer in my signers array that I've created here. And then we'll just log some information about the deployed contract. So if I run npx hardhat, run scripts, deploy.js, and specify that I want to use the network Goerli, this should run for me. All right, so this took a little bit, but we were able to deploy our money router contract, which is excellent. So I have the address now. Now what I can do is start interacting with this contract. So the first thing we want to do is send some money into the contract itself, right? So we want to call this send lump sum into contract function. Maybe I'll zoom back out a little bit more. So to do that, the first thing I have to do is approve the contract to spend some of my DIX so that we can then call that and have some DIX go into the contract itself. To do this though, I need to actually get some DIX first. So let me show you where you can go get some fake DIX inside of our docs. So if you go to docs.superfluid.finance, which we'll do here, we can go into the interactive tutorial section and to our super token faucet. Let's refresh here. These sometimes take a second to load. They are a bit heavy in line, but this is useful for getting tokens. Okay, so I'm connected here. Let me check what network I'm on. I'm on Goerli. Fantastic. And I'm going to click this to get some DAI. Alrighty, I'll confirm. And we'll go check this on Etherscan. Okay, so this faucet worked. I now have 100,000 fake DAI. And what this also did is it also sent me 0.01 ETH on Goerli. So this would be really useful for you to use. Again, all you have to do is call this here, and you can call this once every 12 hours. It'll give you quite a lot. This actually is wrong. We should say this is going to give you 100,000 fake DAI instead of 0.01. I guess no, this is correct. You can connect your wallet at app.superfluid.finance to get 1,000 fake DAI. But here, you can become a whale on Goerli and get 100K in each call. Okay, so now we have lots of DAIX in our wallet. This means that we can work with our contract. Okay, so next step will be an approval and then calling that function to send funds into the contract. Okay, so let's go into our token approval script. I'll copy the address of the money router. This script will walk you through exactly what's going to happen. You can see this inside of the repo itself too as you go through it. But let me just paste in the money router address to this section. Again, you'll notice that the provider and initialization of the framework look exactly the same. You'll notice that we're getting the same array of signers. Except this time, what I'm doing is getting this contract address for the money router and using the Superfluid SDK to load the DAIX super token contract. So what I'll do here is use the SDK to just call a function on the DAIX contract to approve the contract to spend our funds. You'll notice that this looks exactly like how the standard ERC20 approval method works. Okay, so what I'm gonna do, I'm gonna create this operation first. So I'm gonna call this approval operation, and we will call DAIX.approve. And then we have a receiver who's going to be our money router contract. So I'm just going to pass in the money router address. And then we'll have a super token we're going to approve, which is going to be DAIX. So we'll pass in the address of DAIX. And then finally, we have an amount, which is going to, in our case, be, let's send 1,000 DAIX into the contract. Okay, so we'll do ethers.utils.parseEther. And pass in the string of the amount we want, which is going to be 1,000. What this ethers.utils.parseEther will do is give us 18 decimals on top of what we put in here. JavaScript doesn't work with big numbers very well, so you do need to use a library like this to work with big numbers. All right, so if we actually wanted to execute this, we can just call await approval operation.exec and pass in the signer we want to use. So in our case, it's just going to be the signer. The first signer, so signers of 0. And then I'm just going to console.log the output as soon as this completes. Okay, so let's save that. And then this time I'm going to run this script. Let's see, this is token approval.js. And then again, we need to specify Goerli as our network. And this should be processed here momentarily. All right, fantastic. So we have this come back. We have a transaction hash. We have some information about the transaction itself. Let's go to Etherscan and make sure this was indeed processed correctly. Let's go check it out. All right, looks like it's just pending, but this should work. Okay, fantastic. So we've approved the contract to spend 1,000 DAI on our behalf. Now we can call this lovely function here. Okay, so this will transfer money from our address into the contract. So let's run this send lump sum to contract function. So if I go up, I need to copy the money router address again. This is going to be necessary for us. We'll paste that in right here. Same thing, get the provider, get the framework, get the signer, get the contract of the token, and get the contract of the money router. Here, this is really simple. We can just use ethers to make this call. So we can just call await money router.connect to send a transaction from a specific address. So we'll do signers of 0 dot send lump sum into contract. And let's make sure that wording is right there. Send lump sum into contract, and then we need the token and the amount. So in our case, what we need to do is pass in the DAIX address and then amount. So let's just send all 1,000 of what we had into the contract. So we'll do ethers.utils parse ether with 1,000. Okay. And then we will make sure I got this right here. Let's expand my screen a little bit. Okay. And then we'll call console.log on the output. Okay, so now I'm going to run this script. In this case, this one is called send lump sum to contract. And what this is going to do is seed our contract with money we can use to stream funds out, right? This will help us with creating money streams out of the contract. And it looks like this was also successfully run. Let's just verify it once again on Etherscan. Here's my last transaction. That approval was successful, which means that our sending of funds into the contract should also be successful. Again, just as a reminder of how Solidity development works and working with tokens and the approve transfer from pattern, if you didn't call approve first, transfer from inside of the contract would not have worked. Okay, that's key to keep in mind also for the kind of dynamic we'll use for providing the contract with the ability to create, update, and delete streams on our behalf as well. The system is very, very similar. Okay, so this is indexing, which means that it's probably gone through. Now, what we should see is that our contract has some super tokens. So let me go into the Superfluid console and copy this address. Boom, we can see this was successful. And if I paste in an address on any network, the second that the Superfluid console is able to index this address, it will do so the second that something happens within Superfluid and this contract. So if it has some super tokens, if it's had a stream created into it or out of it, we'll be able to then track what's going on with this contract. Any second now. Sometimes it takes a moment to index. Okay, we can see it pop up there. It's been indexed. And we can see, if we go to super tokens, we've got a balance of 1,000 DAI-X. In our case, this is called F DAI-X because it's fake DAI on Goerli. All right, fantastic. We have 1,000 tokens inside of the contract. Now we can create a stream from the contract. So we can call the create flow from contract function. And that we can do right here. So again, I'm just going to pass in the address of the contract. I also need an address to send money to. So I'm just going to pick a different one of my addresses inside of Etherscan. Let's see, who do we want to create a flow to? Let's create a flow to my account 2 here. I'll paste in this address. Same thing, the setup is identical. Now we just need to call the function on the contract to do this. Okay, so we just pass in the receiver, token, and flow rate to create flow from contract. All right, so inside of create flow from contract, what we'll do is, once again, just use ethers. MoneyRouter.connect. We'll pass in the first signer. And we have the receiver, token. Oh, let me make sure I spell that right. Token, which is just going to be DAI-X.address. Then we need to pass in a flow rate. Okay, so the flow rate, in the case of this call, we'll pass it in as a string, right? Because it is effectively just a number. It's an int96 value. And what we need to do is pass in an amount per second in way. So if you want a shortcut for calculating monthly amounts for streams, we once again can go to our docs, and inside of the money streaming section, all the way at the bottom, we can leverage this to enter an amount in Ether and then calculate a flow rate. So let's assume that I want to stream all $1,000 per month that I just sent into the contract. Just entered an amount. Sometimes this can take a second to load, as I mentioned. These can be a bit heavy inside of the docs. Then we can calculate the flow rate, and boom, I get the flow rate that's going to be equivalent to 1,000 tokens per month. Okay, so I'll put that there. If you want to see the math on that, you're welcome to just use this code sandbox. To view that, you can use that same math yourself. And instead of maybe calculating just things on the monthly basis, you can also calculate daily, weekly, annually, whatever you want. Okay, so then we'll just console log the output. And this time we will just call create flow from contract. All right, and this should complete in just a second. Looks like it did. Okay, so while we wait for that to complete, I'll just briefly talk through the other scripts, right? So if you want to do the update flow from contract, I won't go through this on this video because it's exactly the same process as the create flow from contract. The syntax is almost identical, except you just replace update here. And make sure that the flow already exists that you're updating, okay? So that'd be the update case. And in the case of deletion, we just replace this with delete. And instead of having a flow rate as a parameter, we just need to pass in the receiver token and receiver. Instead of, and then in the delete case, we just need to change this to delete and then pass in the receiver and token, right? And that will take care of it for us. Once again, fairly simple. I think you're smart enough to figure out how to just replace those and create your own script, but that's an explanation of how that would work. So if we go to the console and we refresh on this address and go to streams, we should now see a stream coming out of the contract, right? So there's no stream going into the contract yet, but we can see that this balance is being ticked down in real time because a stream is open from the contract, right? We just created a stream at roughly 33 tokens per day, which is going to add up to roughly 1,000 per month, and we're already streaming money. So you have just created a contract that can receive super tokens and send them out in the form of a stream. The last step here is figuring out how to create a stream into the contract using the functions we wrote on our contract itself, okay? So again, if you'd like, you can very easily create a stream into the contract using our SDKs. There are lots of great SDK examples inside of our documentation. We even have a full walkthrough on the SDK core itself, which walks through each and every one of these tutorials to show you how to build React apps that don't even use Solidity at all. They just use JavaScript to create streams into a contract or to another address at all, right? In our case, we're not going to do that. A lot of people ask us, how do I create a stream into a contract? And until recently, we actually didn't have the ability to easily do this in Solidity. You could do it using the CFA library from another contract, but if you wanted to just call a function on a contract and send money from an EOA into that contract, you needed something called the access control list to do so. So recall inside of our contract, what we created were these functions that use this create flow by operator function and the update flow by operator function. And we pass in a sender in addition to the receiver and the rest of the parameters. What we have to do before calling these is make the contract the operator and give it a flow rate allowance. So this is a lot like approving with an ERC20 token our contract to spend a certain amount of tokens and then calling transfer from after that. It's very, very similar, right? You can think of it in much of the same way. So the first thing we have to do to actually make this happen is run an ACL approval, okay? And just like we did in our previous example, let me paste in the address of the money router. So I'll set this here. Again, the setup is exactly the same. And let me show you in our repo where you can see a finished version of what this ACL approval looks like. So let's go back all the way over to our examples. So go to examples, beginner examples, money router, and then inside of scripts and ACL approval, we can see what this looks like, okay? So what we need to do is call this update flow operator permissions on the CFA v1 object here, okay? We'll need to put in a money router address as our flow operator. We need to add a super token, provide a flow rate allowance, which gives the operator the ability to create streams up to that amount. And then we need to add a permission type, okay? So let me just copy this whole section and we'll walk through it in a bit more detail together, okay? So let's go right here. Delete the duplication there. Okay, so here we go. We have the sf.cfav1.update flow operator permissions, and we have this information here. Okay, so we need to add a flow operator, which is just like the spender in the case of the ERC20 approve, except this time our operator is going to be the contract address. In terms of the super token, this looks pretty similar, right? We just pass in the DIX address. But flow rate allowance and permissions are a little bit new. Okay, so the flow rate allowance defines the total flow rate that I can have tallied up amongst all of the flow creation and update events that happen. Okay, so let me give you a concrete example here. If I create a stream worth 5,000 tokens per month, what that would do is it would reduce my flow rate allowance by 5,000 tokens per month. If I then update that flow with an increased amount, let's say I update it to 7,500 tokens per month, my flow rate allowance will not drop by another 7,500. It will drop by an additional 2,500, right? Because I'm making an incremental increase in the flow rate for the EOA that I am the operator for. Now, what does not impact the flow rate allowance are deletions. So if I give someone a flow rate allowance of 100 tokens and they use up a few of those in their flows that they're creating, but then they decide to go start deleting flows from me, what they can do is delete as many flows of me as I'd like if I provide them the permission to be able to do so. Okay, so you have to think very hard about what level of permissions you're going to provide your flow operator and how much you want them to be able to increase or create for you on your behalf in terms of streams, okay? So the permissions and the information about the flow rate allowance can be found in detail in our docs inside of the Superfluid Solidity docs under the access control list section. We walk through how this function works. We walk through revoking flow operator permissions, all this good stuff. The permissions themselves correspond to a number value. So if you want to just allow a flow operator to create a stream on your behalf, you can pass in a 1. Just update would be a 2, create or update a 3, and so on and so forth. In our case, for our example, we're going to provide full control, create, update, and delete. So we'll pass in a 7. And then on flow rate allowance, we provide a good explanation of how this works and some edge cases around it, right? Again, it explains how flow deletions do not impact the flow rate allowance and how flow increases do impact the flow rate allowance, flow decreases do not, all that good stuff. In our case, we'll keep it very simple. We'll provide a fairly high flow rate allowance and just create a simple stream as a result of that, okay? So again, any questions here, I would recommend going to this section of our docs. Again, CFA access control list, and then ask anyone in the Superfluid community if you have any questions, all right? So if we run this, what we're going to do is provide a flow rate allowance of 10,000 tokens, which is what this amount equates to in terms of flow rate allowance per month. So the contract will be able to create on our behalf streams worth up to 10,000 tokens per month. Okay, so let's call the ACL approval script. Okay, fantastic. You can see here that the what's being logged is a bit different. I have some more optimized promises here. So in this case, I'm just going to log something specific, and then we're only going to get the transaction hash. So I can pull it up if I want to on Etherscan. This was successful. Now what we can do is call the create flow into contract function. So again, pretty simple. We just need to pass in the token and the flow rate because there's no receiver. The receiver is implicit as the contract. So let's run this. Let me go first and where are we at here? Let me just grab our money router address really quickly. I'll head over to this section. We pass in the address of the money router. Our setup is exactly the same. And let's go ahead and call this function. So we can just call await. moneyrouter.connect. Then we pass in our first signer as the signer of this function call. And then we're just going to call create flow into contract. And once again, we're just going to pass in the token. So this, in this case, is going to be DIX.address. And then we need to pass in a flow rate. So I'll come back to the flow rate. And what do we want to grab here? Let's just grab the same flow rate that went into the contract. about 1,000 tokens per month. And that was the amount that's going out of the contract. Let's make sure that whatever's going into the contract is the same. And then we can run this function. So what this is going to do is open up a stream from us, the EOA calling the function, so in this case, the first signer, into the contract. All right. Wonderful. Okay, so we now have a stream going into the contract. As soon as that propagates, we'll be able to see that. But just to recap, here's what we did. We deployed a contract, which allowed us to send a lump sum into the contract, create streams out of the contract, and then also create streams into the contract as a way of funding it. We have some scripts here on the side that you can all find in our repo in this money router section under scripts. You can see it all here. We deployed the contract using the deploy script. We approved the contract to spend tokens on our behalf, and then we call a function to send a lump sum into the contract on the contract, right? That function is on the contract. So it will pull money from our EOA into the contract itself. From there, we have money into the contract, so the contract can create a stream. So we call this function, which is titled create flow from contract here, to send money to this receiver in the amount of roughly 1,000 DIAX per month. Then what we did to round it out is approve the contract to be a flow operator on our behalf to allow it to create streams on our behalf. And we allow it to create about 10,000 tokens per month worth of flows. And we then from there can call the create stream into contract function to send a stream from us, the EOA, into the contract by calling a single function on that contract. So in the end, what we have is this. We have both an incoming stream and an outgoing stream. In our case, it's exactly the same amount. So the net flow rate is actually 0 for the contract. It's not receiving more than it's getting, and it's not sending more than it's receiving. Its net flow rate is 0 for DIAX, right? So if you were to call the get net flow function in our SDK or on the constant flow agreement contract, you see that it's 0, right? This is basically having a negating effect on the contract's balance through time. Okay, not much is really happening by way of increasing or decreasing the contract's balance, and you can see that here, right? So you can see that the balance is really not changing; it's stagnant here, right? If I wanted to make this go up or down, I can create another flow into the contract. I can update one of the flows, and so on and so forth, right? This is an excellent precursor to the tradable cash flow. I recommend you watch that video. It's a great one. It's going to allow you to get a handle on super apps to show you how you can do this in a more automated way with some of the more advanced features of Superfluid. But what you know how to do now is create flows into the contract, update flows into the contract, and delete flows into the contract. You know how to work with super tokens, and you know that they're pretty similar to ERC20s when using some of the transfer and approval functionality. And on top of that, you know how to make use of the new access controllers features of the Superfluid protocol. So we encourage you to get started with this. We encourage you to fork this, make this better, make it fit your own use cases, and reach out to us if you want to build anything, right? The Superfluid console is here for you. The documentation is here for you. Our fancy, or maybe not so fancy token faucet is here for you, and we are here for you. So thanks so much for watching. Please connect with us in Discord, and we will talk to you soon.